This video looks at another example of integration by trigonometric substitution. So it's just one more example. Okay, let's say we have been asked to complete the integral of 1 on, or evaluate the integral of 1 on 1 plus x squared to the power of 2, integrated with respect to x. Okay, well, one thing we could do is looking a bit like 1 over 1 plus x squared, if you ignore the square up here. So it's suggestive of tan. Well, one thing we can do is let x equals tan theta, so that dx becomes sec squared d theta. Theta is, in this example, will be limited to 0 to pi on 2. And use the relation, the trigonometric identity 1 plus tan squared theta is sec squared theta. Okay, well, coming back to the original question, the integral of 1 on 1 plus x squared all squared with respect to x is the integral of, substituting in there, 1 plus x squared is 1 plus tan squared, so that's 1 on sec squared theta squared, okay, times dx d theta, okay, d theta. Okay, well, dx d theta is going to be sec squared, so we'll put sec squared in there where dx d theta is. We can just see here dx d theta is sec squared theta. And so evaluating this, we have 1 over sec theta to the power of 4, okay, times sec squared theta d theta. And so we'll end up with 1 over sec squared theta d theta. That's our integral. Okay, now sec theta is 1 on cos theta, and so by the same token 1 on sec theta is equal to cos theta. Okay, so we have 1 on sec squared theta is cos squared theta, and from previous videos we can use the identity, replace cos squared theta with a half times 1 plus cos 2 theta integrated with respect to theta. When we do that, we end up the antiderivative of a half is theta on 2. The antiderivative of cos 2 theta is 1 on 2 times sine 2 theta, but there's a factor of a half out front, so this becomes 1/4 plus our constant of integration. Okay, what do we do now? All right, well, let's go back to our relation we had. Tan theta was x, but we could see that as tan theta is x on 1. And if we look at a right angle triangle, from right angle trigonometry, we set up a triangle here, right triangle with the base 1 and the vertical height x. Okay, the angle theta here, then tan theta is opposite over adjacent, x over 1, which is just x. Okay, and by Pythagoras, because it's a right angle triangle, this will be the square root of x squared plus 1. All right, well, looking at the same triangle, sine theta is opposite on hypotenuse, so that's x on square root of x squared plus 1. Cos theta is adjacent on hypotenuse, so that's 1 on the square root of x squared plus 1. And our sine 2 theta term here now can be written as sine 2 theta is 2 times sine theta cos theta, so that's 2 times x on the square root of x squared plus 1 times 1 on the square root of x squared plus 1. And simplifying that down, it gives us 2x over x squared plus 1. Okay, now tan theta is x, so that theta is inverse tan of x. And so up here, our theta on 2 becomes inverse tan x on 2. The second term here, 1 on quarter times sine 2 theta becomes x over 2 times x squared plus 1. This 2x up here disappeared and became 1x because we had a factor of 4 here. Okay, so 1 on 4 times that gives us 1 on 2. We have then final result is the integral of 1 over 1 plus x squared all squared, integrated with respect to x, becomes inverse tan x on 2 plus x on 2 times x squared plus 1 plus the constant of integration. And that's it.